That fossil, it appears as a big boulder or a rock. We need to crack open that rock or the layers of minerals to expose the bones or the bone fragments such as teeth, ribs, vertebra, nails, etc. Okay. Okay. Like it has been divided into eras. We have three eras: Paleozoic, Mesozoic. Mesozoic era means the era of the dinosaurs, and the Holozoic. So we get a lot of fossils. But break in fossil record. There are periods of geological time in which we get no fossils. These demarcate that there was a huge shift or paradigm shift in the geological history of Earth, marked by the mass extinctions. Students, welcome back to B2S Academy. Today we will continue our lesson on the chapter evolution. Today we will look into the various evidences of evolution, the theories regarding evolution, and the merits and demerits of the theories. So let us start our lesson with evidences for evolution. Now, since the 16th century, 17th century Europe, scientists were looking into whether evolution really happened or not. It was a hotly debated topic. Some people who were from the churches, such as the priests or the clergymen, they refuted evolution. So those kind of people, the religious minded people, they thought that okay, evolution is against the doctrine of God. So society was divided. But the scientists settled this debate once and for all with the discovery of fossils or fossilized organisms. Now, what are fossils? Fossils are the preserved remains of dead plants and animals, even fungi, microbes, protists, monerans, algae, anything, any living matter. If they are preserved or parts of them are preserved in rocks, okay, they are regarded as fossils. Now obviously all those fossilized animals were dead long before. Okay, some of them died millions of years ago, some of them died a few thousands of years ago, but it's a long time. So those remains which are preserved naturally, okay, in nature, they are termed as fossils. So fossils can be of animals, of plants, of fungi, of bacteria, anything. Okay. Fossils can be of any living matter or any living organisms. Now, what are the types of fossils? One are the unaltered fossils. The unaltered fossils. What are unaltered fossils? Unaltered fossils are when, in very, very rare circumstances, the entire organism is preserved unchanged for thousands of years. Their entire body is preserved as a fossil. They are known as unaltered fossils. By entire body, we mean not just the skeleton, but the skin, the bones, the muscles, the hair or the scales on their body, anything, the entire organism as it was when it was living, if it is preserved intactly for thousands of years, it is known as unaltered fossil. Recently, we came across two unaltered fossils. One was a woolly mammoth discovered from Siberia, which was 25,000 years old. Its body was recovered intact as it is. Even its meat, its tissues, its blood, its hair had not decomposed. Similarly, from Russia, we had discovered a ancient cave lion baby. Okay, it was an unaltered fossil. This entire body, along with its skin, hairs, bones, teeth, nails, everything was preserved, unaltered, unchanged. Okay, as if it is sleeping, but it has been dead for around 25 to 30,000 years ago. Another type of unaltered fossil that we encounter is the amber encased insects. Plants, especially some gymnosperms, they secrete a thick, waxy, resin-like substance called amber from their barks. Now, this amber is very rich in nutrients. Okay, it consists of cell sap only. So, various insects like flies, mosquitoes, they sit on those amber to feed, and they gradually get stuck in that amber, and the tree encases them. The tree encases them in that amber, and the insect does not decompose. It remains trapped in that amber, albeit dead, for millions of years. Okay, so amber encased insects and such are examples of unaltered fossils. Next, we have the petrified fossils, or the most common type of fossils. The petrified fossils are produced when an organism dies near a water body, preferably a fast flowing river. Now, what happens? It dies on the river bank, and the river deposits silt on that body, and layers of silt and sediment accumulate, under which the body gets trapped and buried. Okay. Then what happens? The minerals in that silt and sediment, they replace our organs, muscles, tissues, blood. Okay, and they encase our bone with that mineralized material. The bones of the animals remains intact. They are not replaced by any mineral. Although the bones undergo a chemical change, so they change their color and density also. But since bones are trapped inside, or they are encased within the muscles are replaced by minerals. It is known as petrifaction or mineralization. So this mineralization traps the bones inside the minerals, and when we recover that fossil, it appears as a big boulder or a rock. We need to crack open that rock or the layers of minerals to expose the bones or the bone fragments such as teeth, ribs, vertebra, nails, etc. Okay, these are known as petrified fossils. Petrified fossils are sometimes found as intact skeletal system, though they are very rare. Most of the time we find petrified bone fragments only, because due to thousands of years of pressure, some fine bones, they crack, they disintegrate. Also during extraction, most of the fossils gets damaged, and for fossilization the body needs to be intact. Okay, if the dead body is scavenged upon by the scavengers, okay, it will not work. The decomposition should not be very rapid, it should be slow, it should be gradual, and fossilization takes a lot of time, so that particular place should remain unaltered or unchanged for thousands of years at least. Okay, with no major geological changes, climate changes, geographical changes or man-made changes, then only fossilization will occur. Then only we can get a nearly perfect fossil, but that is not the case. This is an ideal situation which seldom happens. So for petrified fossils, we seldom get the entire skeleton, we get bone fragments. 99% of the times, the paleontologists, scientists who study fossils, are known as paleontologists. Okay. They are paleontologists. They study fossils. And the study of fossils is known as paleontology. Okay. The paleontology. This is the study of fossils. So, these scientists, they recover the bone fragments and they identify which phylum it belongs to, which class it belongs to. Okay. Next is the mold fossil. Now what happens? Suppose an animal dies and sinks at the bottom of a water body. It will then fall in the mud where its body will get trapped and will get decomposed. But over thousands of years, the imprint of that animal, the three-dimensional imprint of that animal, which remains engraved in the mud, it gradually hardens and forms into a stone-like slab containing that 3D block or mold-like shape of the animal or plant, indicating its external outline. These are known as mold fossils. And if the molds of the mold fossils are filled by minerals, mineralization of the mold occurs, then what we get is a three-dimensional cast fossil. Cast fossils are seldom found in our homes. Some of you may be aware of the shaligram, which is considered as holy and worshipped as God. That shaligram is nothing but a cast fossil of a extinct molluscan group called ammonite. Okay, so shaligram is an ammonite, which is a mollusk. Okay, extinct mollusk, ammonite cast fossil. What happened? The ammonite animals were shelled animals. Okay, they died, they decomposed, and their shells formed mold underneath the ocean or the river. Now the shells are very soft, they are made of calcium carbonate. They got broken and disintegrated, but the mold or the imprint, the three-dimensional imprint they left behind in the mud, they got filled up with minerals, forming a three-dimensional hard cast known as a cast fossil. Next we have the print fossils. Now what are the print fossils? Print fossils are nothing but footprints or imprints of leaves or imprints of skeletons, just the imprint. It's a two-dimensional thing, or if it in the case of footprints, it's a three-dimensional thing. These are known as print fossils. It's a very bad analogy, but you must have seen that when a block of cement is used to pave a road or a sidewalk, cats and dogs walk over it and their footprints are left behind. Even after the cement has hardened, you can identify that, okay, this is the footprint of a cat or a dog. If this thing occurs in nature over thousands of years, what we get is a print fossil. And the last type of fossils, we have the coprolites. Now what are coprolites? Coprolites are nothing but animal excreta. Okay. Animals, they defecate, and when the defecation is near a water body or in a soft mud or sandy region, their excreta, their fecal matter gets covered in mud, sand, gravel, and gradually the excreta, the organic matter contained in the excreta is replaced by the minerals of the soil. Again, mineralization occurs, and what we are left behind is a coprolite or fossilized animal excreta. Okay. Now, fossils are found in various periods of geological time, which we call as the geological time scale. Okay, like it has been divided into eras. We have three eras: Paleozoic, Mesozoic. Mesozoic era means the era of the dinosaurs, and the Holozoic. Okay, sorry, the Cenozoic era. It has got three parts. Era, I am writing here. The Paleozoic, the Mesozoic, and the current. This is the current, the Cenozoic. Okay, this is the era of dinosaurs. Now, eras are divided into periods like the Mesozoic. The Mesozoic has three periods: the Triassic, the Jurassic, and the Cretaceous. And all these periods are divided into epochs. Okay, epochs. Like the Cenozoic had, in the Cenozoic, the current epoch is the Holozoic epoch. Okay, these are not important for your syllabus. Now, all these periods and the transition between eras, periods, epochs, okay, are followed by mass extinction. Like the Cretaceous period marked the end of the dinosaurs, because at the end of the Cretaceous there was the KT extinction event which wiped out the dinosaurs. The KT extinction event. There have been at least 5 recorded mass extinction events. The KT is one of the most severe, which wiped out the dinosaurs. The dinosaurs. Okay. K stands for the Cretaceous and T stands for the Tertiary, the first period of the Cenozoic. Tertiary. Okay. This T stands for Tertiary, the first period of the Cenozoic era. And before and after a mass extinction has occurred, we get a lot of fossils. But during the time of mass extinction, okay, there is a dot or gap in the fossil record. See, when many animals die together, it marks the end of an era or the end of a period, okay, or the transition. So we get a lot of fossils. But break in fossil record, there are periods of geological time in which we get no fossils. These demarcate that there was a huge shift or paradigm shift in the geological history of Earth, marked by the mass extinctions. So these all are the evidences that indicate that yes, evolution has occurred throughout the history of our planet.